All right, hello and welcome once again. We're working on review for chapter 9. All right, so we're going to go over selecting electrodes really quickly to make sure we understand. So the American Welding Society has an electrode classification system, and it gives us whether it is an electrode or a rod. It identifies its tensile strength, welding position, type of coating, as well as polarity. Okay, so we have E for electrode. The first two numbers are tensile strength. The 1, 2, and 4 talk about position. 8 is the type of coating and polarity. We can also have other things for impact strength, less than a percentage of hydrogen, as well as absorbed moisture tests. We know that AWS has 4 groups: F1, fast fill; F2, fill freeze; F3, fast freeze; and F4, fill freeze. Okay. We also know that we can have different types of alloying elements into low alloy steels that help them do different things. Okay, we can also have an alphanumeric suffix, which means -A1, and it tells us a percentage of carbon, nickel, silicon, chromium, vanadium, or whatever percentage we want with a suffix instead of having to write the whole thing out. Deposition rate is important. We know how fast can we put the weld down is just as important as how well can we weld. All right. Oh, wrong way, guys. All right, we can also understand that stub loss is a big deal. Time is money, and loss of material is money as well. All right, so we know that if we can put the diameter of our electrode into a decimal, we can create a ballpark for 90% of the rods that we look at. Okay, we can also use an electrode selection chart like this one, and it helps us find the best electrode for some of the variables that we have. Okay. All right, so some electrodes are designed to work with direct current only, some with AC, and others with AC and DC. Okay, we want to make sure that we select the correct electrode for what we're doing. AWS A5.1 is a specification for carbon steel electrodes for SMAW. AWS A5.5 is a specification for low alloy steels for SMAW. When we weld with direct current, we need to make sure that we have the correct polarity, electrode negative or electrode positive. And we know that AWS organizes electrodes into 4 major F groups based on their characteristics. When we use a low hydrogen electrode, after it's been opened, the electrodes must be stored in an oven between 250 to 300 degrees. We want to store all electrodes in a dry place so that the coating can't be damaged by moisture. So that means not in the back of your truck. All right, so what is the function of the coating on an SMAW electrode? The coatings contain various elements like cellulose sodium or titanium sodium, and they act as a cleaning and deoxidizing agent to remove impurities and oxygen from the molten weld pool. They produce shielding gas to prevent the molten weld pool from reacting with oxygen and nitrogen, form a slag coating over the weld bead to protect it from oxygen and nitrogen as it cools, as well as slowing the cooling rate to make a more ductile weld, provide easier arc starting, stabilization of the arc, and reduce spatter. And they also permit better penetration and help meet weld quality requirements. What has done to ensure uniformity electrode specifications? AWS has made a classification system that consists of numbers and letters and can add additional operating characteristics to show somebody what it is, like kind of an abbreviation. What symbols have been adopted? Well, we know it. E for electrode, da-da-da-da-da-da. Now explain the identifying symbols of the electrode classification. E for the 2 numbers. 60 is for. The number 1 tells me what position. And the 0 tells me what type of flux and what polarity. All right, what is an all-position electrode? Okay. When we look at an all-position electrode, is a low hydrogen electrode that is capable of producing sound welds with excellent notch toughness and high ductility in any welding position. How can the current and polarity an electrode is designed for be determined? Well, we're going to look at the last number, and then the current and polarity can be determined by the electrode coating, melt rate, and weld position. What factors should we take into consideration when we select an electrode? Well, there are 7 factors. Base metal properties, electrode diameter, joint design and fit up, welding position, welding current and polarity, production efficiency or deposition rate, and end service condition. Why are smaller diameter electrodes used for overhead welding? When making vertical or overhead welds, 3/16 is the largest diameter electrode that should be used because larger electrodes make it too difficult to control the deposited metal in. We don't like it to rain on us. All right. What precautions must be taken when we store electrodes? Well, we want to make sure that they're dry at a normal room temperature and a maximum humidity of 50%. Why are low hydrogen electrodes used? Well, iron powder electrodes are designed for low carbon steel. Let me see. Iron powder electrodes are designed for welding low carbon steel where high travel speeds and high deposition rates are required, i.e. jet rod. Why are low hydrogen used? Well, they're designed for welding high sulfur and medium or high carbon steel as well as thick sections. Low hydrogen electrodes were developed to prevent the introduction of hydrogen into the weld and heat affected zone. What are some of the specific characteristics of electrodes designated as fast freeze? Fast freeze is the F3 group. It produces a crisp, deep penetrating arc and a fast freeze weld bead. Fast freeze electrodes produce a thin, tough slag and a flat to slightly concave bead. They're used for all position welding for fabrication, repair work, and joints with poor fit up. They are preferred for vertical and overhead positions. Some electrodes are fill freeze. Okay? Fill freeze, or F2, is an electrode that has a moderately forceful arc and a medium deposition rate. The arc and deposition rates are those between the fast fill and the fast freeze electrodes. Fill freeze electrodes produce easy to remove slag, a weld bead with distinct even ripples. They are general purpose electrodes used in production shops and are particularly used for sheet metal, repair work, and joints with poor fit up. What types of welding are fast fill electrodes for? A fast fill, or F1 electrode, is an electrode with high iron powder coating that has a soft arc and high deposition rate. It produces a heavy slag that is easily removed and exceptionally smooth weld beads. It is generally used for production welding where work can be done in flat or horizontal position. What is the function of slag? Well, slag protects the weld bead from the atmosphere as it cools, slows the cooling rate of the weld metal to help make a more ductile bead, and may contain deoxidizers and scavengers to remove impurities from the weld. How does joint design affect the diameter of the electrode used? On thick metal with a narrow root opening, a smaller diameter electrode is used to deposit the root bead. This ensures complete penetration into the root of joint. Successive passes can be made with larger rods. All right, what organization is responsible for establishing a standard numerical electrode classification? AWS, or the American Welding Society. Which F group includes deep penetrating electrodes? That would be F3 or fast freeze like E6010 electrodes. How are electrodes marked for identification? Well, they are imprinted with the classification number on the end. How should low hydrogen electrodes be stored once the seal on the moisture-proof container is broken? Once it's broken, they should be stored in a ventilated electric holding oven between 250 to 300 degrees. Thank you. Come again.